Everybody that asked to join the panel has been added. How is everybody?
Hey. Oh, good. We have Roohif here. Excellent.
Hi. Is that PJ?
How you doing, Roohif? Let me put on my camera since you're doing that. How you doing?
I'm probably going to turn mine off shortly.
You're okay. Yeah. How you doing, everybody? How you doing, Ranty?
Yeah, I'm doing good, thanks, Pete. I'm sort of refreshed after the weekend, actually. It's 1:45 and I'm still raring to go. I thought I'd be a bit tired, but, you know, I'm not actually. So we can probably get a good hour and a half in, perhaps, on this. And so, if, you know, just it all depends on how long people want to stay, really. Did you enjoy the presentation?
I didn't actually watch much of it, to be honest.
Yeah, it was just as good as the first time.
Cheers.
Show your face anyway, Roohif. You're going to have to sort of defend not that you're going to have to do anything, but I mean, it's sort of indefensible, really. It'd be an insult to our intelligence. It'd be at least it concede something, I guess, at this late stage. Yeah.
We'll see. Yeah. Like I said, I don't really. I watched maybe 15, 20 minutes of the stream, so.
Yeah, you get the general gist, right?
Oh, it was about refraction. Was it actually just a repeat of the Jeranism chat that he had on his channel? Is that right?
Yeah.
Oh, okay. All right. I didn't watch that either, but yeah, that explains why it was pre-recorded. Yeah.
It's the same issues, right? From day fucking one, it's been the same issues, just across the board. Simple as that. And this should all be settled for, let's say, flat earthers, especially upon sort of calling ourselves flat earthers. You know, decide these issues yourself, and then we'll take it from there, I guess. And here we are now, taking it right back, I guess, Roohif. I mean to pick on you. I'm not picking on your end, and I'm just talking here. I'm not sure if anyone else wants to get in or what's the story, but I was just saying, I mean, just in terms of the whole, to sum it up, right? It's everything. So we have the visuals, and it's about making sense of the visuals. And when you take in all of these real considerations, well, the ball is ruled out absolutely fundamentally, completely on the basis of everything and all the arguments that have been presented hitherto by the ball, especially associated with the spherical geometry.
I'm sure we'll discuss that shortly. Who we got? Mind of God. Who's Ether Band Boy? Alan Beck is Ali B, right? Chirag Patel's Mind of God.
That would be the Aether Band, Roohif.
Ether Band, whatever. Ether.
Can I just do a quick mic check? Is my voice coming through okay?
Hear you perfectly, Ali.
Ali B's here. I'm out of here.
See you later, Travis.
Oh, it's Travis.
Good man, Travis. All right, I'm going to mute. I'm making coffee, so I'll be listening.
All right.
Let me ask Ranty how you felt that presentation went. I mean, 1,000 people, I suppose, would be tuning into journalism. So that's sort of a lot of pressure in a sense, you know. I'm just saying as the individual. But how did you feel that presentation went? And I also like the way you mentioned the mirrored water there a couple of times as well, and lots of different possibilities to decode what we're actually seeing. But how do you think it went?
Yeah, well, I wasn't making a claim as such. I was just simply putting it out there that from the information that I'd got from the Globers, having spoken with them and how light behaves in their, you know, in their science. And also getting them specifically to address it on a flat plane, what would happen? They all agreed that the light would just bend down, and with that in mind, it gave me the idea of, well, what's the point in having a globe then? You'll get a bottom up obstruction.
You can quiz me live shortly, Ranty. So
yeah, sure, fine. No worries. So the whole
we're not live yet, right?
Yeah, we're live. Yeah.
Oh shit! All right. I was going to open some mail.
Well, the presentation was, like I say, it was just putting it out there. Let's just apply their logic on a flat plane, and hey, you get bottom up obstruction. So more than anything, it was just sort of like removing that exclusivity that the globe has on refraction. Because in Walter Bislin's curve calculator, it doesn't show that. It doesn't show this this drop when you put it on a flat plane. So yeah, just if you remove that from them, if you take that refraction argument away from them, and it's no longer just an exclusive globe Earth refraction only, and you apply it to both, it can be done to both. It's just another arsenal that flat Earth has against the globe. So from that perspective, I think it went pretty well. And it was, like
Excellent.
I say, it wasn't my. It's not my claim per se. It's just taking their argument and applying it on a
Right.
plane. And
Let me just ask.
when I mentioned the mirror layer, that was another point. This evaporation would create the same effect. And I'm more leaning to. I've always been of that. You know, that's always been my position. You know, this atmospheric conditions just above the water, rather than it being a light ray.
Yeah.
But I was going into globe mode there and saying, hey, apply globe mode on a flat plane and you get a bottom-up obstruction. So I think the presentation went well that way. So
Yeah, I mean, it's getting the main point across, and the more people sort of become aware or start asking these basic questions, the better. But I'll just say to bring Roohif in, right, because this is what it all comes back to.
He said he'll be back in a minute. He's just
all right. Well,
step away
what I would ask, right, and it's a general question as well, to any bowlers out there. Isn't this the whole point of it all along? When you saw an image and we're trying to decode it, generally it's because a flat earther brings it to the table. Remember, the globe earthers or the Borler Borg are always sort of reactive, you know what I mean? They never bring anything new because the truth is already delivered to us. But when an image is presented, and according, of course, to the story, the spinning ball Earth model, we shouldn't be able to see it. Then what they do immediately, absolutely immediately, right? Because I have to explain it away because we know immediately it shouldn't be possible. Why? Because it's a fixed geometry. They need to know the observer height. I'm just talking you through the process, right, and the rationale. They need to know observer height, the way they can calculate where, on this image that you're showing me, this visible horizon, which is clearly the visible horizon, it's the geometric horizon, where that begins, and then we'll take into account all of these different manner of atmospheric effects, refraction, looming, and we can bring them into consideration when we're trying to explain what's happening with the target, the visuals with the target, whether it be mirroring, stretching, towering.
Yeah.
I actually think, can you see that shadow moving over my screen there, or is my screen bad or something?
There was a bit then, but yeah, I just want to address Bob the science guy in the chat who says, Ranty, can you think of a test to prove the Earth is flat or not? How would you rule out the flat Earth with a triangle? Listen, how would I prove the Earth is flat? Hey, look, there's a guy that put a video out very recently over a frozen lake. Again, one of numerous ones that he's done. And he saw these laser lights. I think it was up to 9 miles away, you know, from just a few feet, a couple of feet maybe. And he traced it all the way back. It's game over there. I mean, unfortunately, for most of us in this world, we don't live on any ice. You know, for the most part, we don't have the luxury of just being able to go out and film across frozen lakes, unlike this guy, who, I think he's called Grouter1, will actually go out and put the time and effort in to do a very scientific test by doing drill holes and putting the lasers out there. Nobody's got that kind of dedication or will to do that. And he does it, and he proves that water does not curve.
Yeah, let me just jump in real quick if I may.
Sure.
I don't know if either of you watched the video presentation that George Netnuke put together for his test on Rainy Lake up where he lives. Got a lot of static. Have you watched any of those, Ranty or Pete?
I haven't, no.
Well, he entered the scene, Travis, way back with these experiments in tow. I kept waiting for the results, like Rumpus's fucking final thesis, you know, kept waiting for the results, and they were not unconclusive in the end. Just lose interest. But off you go. Yeah, I know about that.
Sure. I'll just make a couple brief statements. If you go to any of those videos, you'll see my comments. And I tried to be as objective as possible. I made a few snide comments, but overall, my honest critiques were there and remain for him to answer. It was clear to me, number one, it was clear that George over and over again simply made declarations about what he believed the atmosphere was doing. He had no statistics or measurements whatsoever. Okay. The second thing is that he consistently and repeatedly showed high refraction, distorted images, and in the same breath says this is very little refraction. Very little refraction going on. We can clearly, and if you just watch it with an open eye, it's very, very obvious that I would say I'm going to give George the benefit of the doubt and say that he's not lying, but that he is a complete smurf.
Well, you can do that all you like, man. You can do that all you like, but you're just kidding yourself there. But they could never concede anything. Let me tell you what proves a flat Earth in a sense. It's more about disproving the ball anyway. But a flat $2, I tell you this, right? In my brain, a $2 mini spirit level that's made and calibrated in China proves that we live on a flat and a stationary plane. Because the bubble will always remain level on a level journey, on a sea journey around a level condition. Simple as that. Otherwise, when I ask for an explanation for that, well, the microgravity is sort of clinging onto the bubble and keeping it in place, even though it's going. No, it's that simple, right? The ball has never existed. It's just utter fantasy. And by engaging people like George, who knows well the Earth is flat, come on, we have to know who we're dealing with here. If you know that some guy is spoofing you, that's one thing. But if you know if you think he's genuine, but you feel there's a bit of spoofing going on, that's one thing. But if you know he's doing it deliberately, that's a different thing. You're going to react differently, right? Everyone is. And we all should be reacting differently to anyone who's fucking blatantly lying, I think, at this stage, right? It's not about what isn't. We know what isn't. It's about now explaining these phenomena. And that's where, Travis, you talk about ether band. There's a very sort of loaded term in a sense, and it's a very sort of fuel topic, necessarily so. And I think it's bringing attention to something real. But all of these things need explaining, and whatever the explanation is, it might have major and will have major implications for our sort of accepted understanding into terms like refraction. All of these terms are defined in terms generally of a ball Earth, right? Inferior mirage is a ball Earth term. It really is, right? Because we're looking at something and we're seeing what we shouldn't be seeing, and we're seeing mirroring underneath, inferior mirage. Now, what is the ultimate cause of that? Well, what is the ultimate cause of that? This is where we need to be sort of focused and have an open mind about everything. As you know, I have my certain ideas, and they absolutely make sense. I wanted to say to Ranty just one point he mentioned, which is very important as well in the presentation. I hadn't seen it before. Journalism, Bob, they all have me banned for some reason. But you mentioned, and I hold that true as well. If you can see a target in the distance, let's say a windmill at 20 miles, fundamentally, you're seeing almost all the way along that water to the target. Because if you weren't, because of the angles, reflection, whatever, all of these things, you wouldn't be able to see it. So you're actually, for the most part, seeing all the way along the water. And the black swan image as well showed you when you're down beyond a certain level, the acuteness of viewing angle, water conditions, etc., allow you to see not just to the targets, but well beyond it as well, all the way along the water. So these are, and I know, listen, let me just say, Rumpus said, no one else on Earth is talking about this. I don't hold that's true at all. The military, etc., they all know about a flat Earth and what water does in terms of perspective when you're looking into the vast distance, right? Even 2 or 3, 5 miles is a massive distance to be looking from our own tiny perspective, no matter what instrumentation we use. So all of these things are known. That's where I think the astronomical horizon is. At the perfect sunset, when the water is calm, you can see as far as you can see. You can identify the real astronomical horizon by the mirroring of the sun, where the mirror line, and this is where the mirror water layer ends, right, and the sky begins, and that can be many, many miles, but it's all compressed to our vision as well. And I think the important thing to sort of try and realize when you're examining this inferior mirages mirroring underneath is understanding that to us it looks like a local mirror, like if there's a lamppost across the river 500 yards away and it almost stretches all the way across the river in terms of its reflection to your feet, that sort of thing. So all these things come into account. But yeah, as regards George or any of these Paul, who is the argument against? Who are we trying to go? That's why I'm underwhelmed with the black swan. Because, all of us flat earthers long since know the earth is flat. And who's there now to argue this? Well, Roohif at least is showing his face. So, if he's a man, right, he'll say he's wrong, or he'll go, I concede something, or I'll reconsider this. And if he's not, then he's something else. So.
Well, to be honest, I've heard enough of this black swan now. There's only so many times, you can only flog the horse so many times, and it is just one video, one image. It is essentially an anomaly. It's like, okay, it is to all intents and purposes the image that, if you take it on face value, it completely destroys the globe, right? The problem is that it isn't something that you can easily recreate. It's not, and that's why sort of like hanging your hat on this particular just one glorious observation over and over. It's a bit like going over that Isle of Man stuff again. You know, it just feels like dragging it on.
You have your own
week
one,
in,
Ranty.
week out. You know, there's no point. I've got my own. I've got my 1 foot observation, but I don't bring it out every show. I don't bring it out.
Make a deal about it. Make a meme about it.
Yeah,
because now it will just add to the weight of the black swan. And let me tell you something. A black swan is a negative term. When you're down the Swanee, you're in trouble, right? When you take a swan dive, you're going down. So that's into the general swan. So a black swan then is more significant still. Affairs like 9/11, the medium victim hoax that it was, symbolic hoax, was described as a black swan event because they say it was totally unpredictable and had magnificent consequences for life in general afterwards, right? So if we know...
Pete, one second, Ranty, can you explain your 1 foot, like just verbally? What do you have that's similar to this, just for people who maybe don't know?
We'll have to think of a name for that, Ranty.
Yeah. That would be good.
More positive note.
Well, essentially, it's just the same as Red Pill Philosophy's video, which, you know, I have to class the two observations. But Red Pill Philosophy's, in my opinion, is a better observation. You know, I mean, I can't claim that I have the best observation, you know, in this domain, because I'm sure there's plenty of other people that have just as Flatser, for instance, doing some excellent observations up in Scotland. But Red Pill Philosophy's observation is absolutely beautiful. It has moving things on it. I mean, my observation is great because you see buildings, you have a lighthouse, you have a whole bunch of stuff there that you shouldn't see on a globe from 1 foot, and it is a beautifully flat, crystal clear, shore-to-shore observation. The difference with Red Pill Philosophy is you actually see cars going over a damn bridge. the bridge shouldn't even be seen.
Mind that, this is not a game. Remember, you're up against, and look, if you think about it in this sense, we're up against the whole of the world. All the higher thinking, the higher mind people, you know, you're up against universities, you're up against educational systems, you're up against just whole empires in a sense. Yeah. So, you know, if one thing, this has been pushed for a reason, by the way, Black Swan, but if that's been pushed, well, you know, I think in general, it's one of those memes, you know, it gets the attention of people, and there's not one person around who hasn't heard about Flat Earth. I think more and more people are taking it seriously as well. So certainly, Ranty, because you're on this path, put out your own, let's think of a different name for it, a more positive name. I'll work on that. Where was it? Barrow on Fergus, was it?
Barrow and Fergus, yeah, but don't confuse what I'm saying, though, that it's that okay, the Black Swan image is what it is, but it is still just it's the anomaly. It's the anomaly of it. If it was like if you saw this all the time, you could literally pin your hopes on it. But just on this one observation, now I actually went and I had a look for the weather data, the meteorological data for the region. I was trying to look at it from a globe earther's perspective. What could I find to explain this? So I was looking at the barometric pressure. I was looking at the temperature. I looked at the wind direction. I looked at everything I could think of that could try and explain this, and there was nothing out of the ordinary. It was pretty, you know, the weather conditions for that entire week were pretty similar. The barometric pressure was the same. There was nothing on that day that would suggest that the weather or the temperature or anything played a part in that image. But something definitely happened on that day because you saw a very long way. But that just makes it the anomaly rather than the norm. And I'm saying just, you know...
Yeah, that's exactly right.
You know, don't flog it to death.
Where does the ether band come into that observation, Travis?
Well, that's a continuing study, obviously, Pete, and that's a great question. I do happen to think that there possibly is a specific variable that might have to be isolated. A couple of things. First, what Ranty just said, the anomaly for me is to see shore to shore. I don't see that in 99% of the shots that I take on the Chesapeake Bay. So when I have a clear shot down to the shoreline, man, that is like hitting a home run. What the heck? A grand slam, right? And so what happened was back in September, I had this beautiful overcast day, moderate temperature, just a beautiful day overall, but it was overcast. And I saw farther and more clearly than I ever had before. The next day, it was exactly the same. I thought I was going to go out, get another clear shot. No way. Not even close. So there is something else going on, because it was still overcast. And as a matter of fact, that same week, Rumpus was on Jose saying, oh yeah, overcast is the best time to get your pictures. And I had 2 days in a row where that was absolutely false. So, what is that variable? I'm not really sure which one to nail it down to. But to go back to what you said earlier, Pete, about the inferior mirage being a term that is attached to a ball model, I've said on my streams, and I'll say it again here, that I actually believe that the superior mirage is misidentified. I don't believe it's correctly identified. I'm going to be so bold as to say that that a superior mirage is really an inferior mirage with a different image.
Okay, I have thoughts on that as well, by the way. And the horizon is never where we see it to be, or where we perceive it to be. It just never is, right? Because first of all, I guess we're sort of you're into a whole new realm of thinking. So if we do live on a flat stationary plane and we're looking over extended spans of water, how should I imagine it looks? You know what I mean? So, but in regards to why Ranty and other people have caught, especially Ranty, because you're down so low, right, and it's so clear. Any child will tell you, yes, you can see all the way across. There's very little trickery going on here. For me, it's water all the way, right? So it's like a puddle. It's like a puddle, and the angle that you're making to it, as you back off from that puddle and you're seeing something reflected, the acuteness of that angle, right, as it diminishes more and more, will allow you to see the layer less and less, if you know what I mean, until eventually, under perfect conditions, perfect stillness, right, then you get down to 1 foot and you're seeing actuality as it is. It's not anomalous. The rest of the circumstances are anomalous, because if I have a door in front of me, then the door is on front of me, right? I can see it. Now, if there's loads of fumes and smoke around, or I'm drunk or something, I was wobbling, these are anomalous situations, but the normal is well settled. So we can all agree that, look, our eyes, cameras are shit at picking up what our eyes can sort of determine about the world, as well as artificiality to it. But getting back to the basic idea here, that's what it is for me, right? We're looking along an extended span of water all the way. So to our perspective, or the camera's perspective especially, the water towards the other shoreline is going to bunch up, sometimes miles, right? So this will behave like a collective, and it will start reflecting. And that's what I think about the drone as well. If you had the capabilities of making these observations. Actually, sorry, I'll do it tomorrow. I'll do it the next night. I'll go to the Skunk Bay footage.
Can I make a point?
Let me just say the Skunk Bay footage, right, itself. If you pay attention to it, I did it at the time 3 or 4 years ago. You can see the mirrored water layer is proven because there's a speedboat going by at the back, right? And as it disturbs the water, the wake, right, the whole of the image starts to get distorted. So it shows that there's something physical mirroring. But anyway, that's a different matter. Someone wanted to get in there.
Yeah, Pete, just while we have Roohif here, kind of what you were talking about, we have this black swan thing and Ranty's observations that are stretching the ball earth model. Does Roohif, you have a comment on that? Just maybe not technical. What do you think about these observations which occur regularly that are stretching the model?
Well, they don't occur regularly, right?
No, they do. We're just not doing them. If you had cameras placed on the shore of every water body on Earth, you would see them lots of times.
Yeah, but not regularly, right? This BMLSB 69 guy, in one of his videos, he actually says he went to the same spot, as many times as he could in the space of 3 months, and every single time it looked like X, and then one day he came and it looked like the photo that I'll actually put on screen now. 1 minute.
But you get what I'm saying. If you put a camera there permanently and everywhere, that would not be an unusual occurrence statistically, right?
It will occur, yes.
Right.
But
so
it's not the norm.
I get that. But
Okay.
Hold on, guys? Can I just hold that thought? I'm just going to post a link in the chat. And this is to the weather report for the October 2016 weather in Miramar Beach. This was where the observation was taken. The observation was taken on Friday the 21st of October at 6:50 in the morning, right? So I'm going to post a link in the chat. So if anybody wants to actually check and try and find out what the anomaly may have been, I can't see it. I'm looking at all the data, the humidity, I'm looking at the pressure, I'm looking at the wind direction, I'm looking at the temperatures. There's nothing really that sticks out here that says that on that particular day there should have been that clear of an observation. But I'm going to put the link in anyway.
And there's so many factors.
Let me just jump in real quick.
To distinguish, right?
Hold on, Roohif, I'm sorry. Just hold on real quick. Ranty, Chirag is really, really low for me. I have to struggle. Everybody else's volume is great, but his is low for some reason. Just to let you know, Roohif, I was in California for the past 18 days taking shots. I was in Santa Barbara at the same location making observations. And so if you're interested, Ranty has some photos. If he wants to pull them up, you can look at what I got as well.
That'd be good. This is Travis.
Can I quickly jump in there as well? I have to agree with Roohif on that not happening every time, like the same as Soundly's pictures. That's the same kind of thing. It doesn't happen. It wouldn't happen very often, kind of thing as well. So we can sort of negate the both, really, because statistically it would happen if Travis has just said 90% of the time he takes them, he hardly ever sees it, even under the conditions. Ranty's kind of the same. That's quite an anomaly. So it's just the same as I say, Soundly's photographs, even though it showed that's like not a normal thing that you would see, that you would see around the world every day. Because statistically, even if it was around the world, compared to the amount of people that did it, the amount of people that caught it would be quite a low percentage, I would believe, if what Ranty does and Travis is saying.
There are maps, so there's
no, I get what you're saying. So, but that sort of negates Soundly's thing, so we can kind of put that to bed, although it was debunked ages ago. That's all I wanted to say. So,
well, there's so many other things that
you've
we
just
can talk
agreed.
about.
1 second, Ranty, but you just agreed with me. It doesn't happen every day. So if the other
Soundly or the oil platforms,
both of them,
I would say
they're the same thing.
Pretty much every day.
No, but you're saying it might happen. It might happen there. It hasn't been observed every day to happen. And like you agreed, if it was taken around the world, it'd be the same statistics as from shore to shore as what you would see with Soundly's. It's not a everyday occurrence, that.
Yeah, exactly. If you don't do
the I haven't seen anyone take Soundly's footage that doesn't show curve.
Yeah, but I mean that got debunked. There's plenty of people that have sort of taken that out. So we kind of agree. That's what I'm saying. I agree with you. You can't really base your facts on these photographs. It's there's something going on there. So we can't really put a stamp on that with the optics that we're seeing at the moment.
Man, Roohif, you're too smart to cite Soundly's Curvy bridge for anything, man. So let's not go there, man.
Yeah, I just wanted to hear him. I just wanted to hear him references.
But Ali, I agree with your point. But can we say roughly? Can we say once a month that would happen? Once a year? Once a decade?
I have no idea. That's Ranty and Travis. They're the guys. They're the only guys that go out there. Tim Osmond goes out twice and says, right, there you go, I've proved it. Where Ranty and Travis, these guys are out every day. Travis has just spent 2 weeks with his camera on the shore for hours and hours at a time, just photographing. Ranty does the same. These are the guys you want to be talking to, not these guys that go on about ray tracing and geometrics and the rumpus giving balls and all that kind of stuff. These are the guys we want to be talking to.
It also seems, Ali, that the murkier the image, the more normal, right? But the clearer or crisper the image, the more anomalous. So this is contradictory. We all know what we're seeing. When Ranty has this 1 foot image, or whoever, was it you who had the oil rig Anacapa Island photography, Travis? I've been hearing your name associated with that. I didn't know.
Yeah, that's me. Yes.
I didn't know. It's not funny. That's funny for other reasons as well. But yeah, you knew. Right, you're seeing this is a version of reality. You might as well you be looking across the road with your eyes. This is because you can go there, first of all. Ranty can go to Barrow and Furnace. He can see it. He can compare and contrast to all the different captures he's got, and he knows the best crisp example of reality that you can find. And to associate anomalous behavior to that crisp picture of reality is a very definition of incommunicability, I suppose. That was a good one, incommunicability. Because
Okay.
you can't relate to that, right? If I say black is white and you say no, black is black, well, if no one is shifting, well, there's no further going, right? And as Roohif, are you open to being persuaded, Roohif? If we were to persuade you right now, and if Ranty was to bring up that 1 foot image, and I was to ask you, is that, to the best of your senses, a real capture of what might be going on in the imagery?
The
Would you be open
foot,
to say yes?
The 1 foot image looks flat. You can quote me on that. It
Okay,
actually looks
excellent.
concave.
Okay,
It actually
right.
looks concave, to be honest.
Hang on, guys. I need to intersect. Right, the Rumpus has pointed out quite correctly that it was the wrong Miramar Bay. I was using the Miramar Bay in Florida. This one's in California. I'm just checking through this now, and the barometer stays the same. It barely changes. The temperature, humidity. There's nothing in this, even still, that would indicate this level of visibility. Right, carry on, guys. I'm going to post this link now anyway.
No, but Ranty,
It's going to be difficult
Rumpus
to go
says
back anyway.
Rumpus says it doesn't matter. You can take 3 numbers in any cube and it'll be okay. So wherever it is in the world, it's fine for him. So don't worry. It's good.
Yeah, it's
Nothing
gonna
to
be
lose. Rumpus is
impossible
nothing to
go back
lose. His
and
face can't go red on
recreate
camera.
the,
I'm making
Roohif's
fun of
can.
him. I'm making fun of him. Bring him in on the call if he's out in the chat.
Don't bring him in because Roohif is on
bring him
camera
in.
at least. His face can go red if he's embarrassed.
Let's move on. Let's go back to what we were talking about. Let's keep on that subject. Forget him. Even when he's not here, he's here kind of thing. Fuck him.
Yeah.
Thank
What's
you.
your
Fuck him.
explanation, Roohif?
Let's go on with the.
What's your
keep talking.
explanation? You say it looks flat, so we say the Earth is flat, right? Water is always level when still. So we're actually looking all the way across the targets. And when we can't see the targets, there's a few different factors involved. It's not the curvature of the Earth. First of all, down so low, you're beneath that mirroring layer. This is where the green flash will be an excellent globe debunker, I swear to you. I'm telling you. Anyway, but Roohif, yeah. So if it looks flat, over what extended span? That's 15 miles or something. Over what extended span then will you admit looks flat, but it still can't be flat because it has to be a globe? Why do you cling to the globe in spite of all the controversy?
Because when you're that close to the surface, the density gradient can be extreme in either direction. So the density gradient can bend it tightly so that it looks flat, or it can bend upwards so it looks like an inferior mirage. At the end, I've got like half a dozen videos about refraction on my channel, right? At the end of each video, I say, don't bother with observations done so close to a surface, because you might have like a cold surface and a warm area elevation and you get extra refraction, or it could be the reverse and you'll get inferior mirages. I always say get some elevation, look at something a long way away with a lot of hidden amount, and you'll have a more predictable density gradient and therefore more predictable refraction.
No, dude, that's just convenient for your narrative, man. Like,
well, when you guys have something hidden at the bottom, you go, oh, it's fucking shoaling or a little 1 foot swell. So how about we all eliminate excuses that we can put on the other side?
Well,
get some elevation.
Your geometric horizon's gone now, so we only have ray tracing.
What do you mean it's
so
gone?
You can't cite that.
So hang on, mind of God. So Roohif,
Well, you
Roohif,
can't
let me
cite
ask you
the
something
physical
else. So hang on, please, mind of God.
Yeah,
Roohif, let me ask you something else, right? Where in everyday life, outside of these miraculous conditions where it appears that we're seeing exactly, clearly as we can see, but where else can you sort of apply your reasoning there? Any other phenomena? I mean, you know what I mean? Does it happen anywhere else in your life that you're confused? I mean, let me just say, in mirages, right? It's another loaded term. We normally associate mirage with extreme conditions. Right? We've got a hot road during a hot summer's day or something like that, or some other conditions like that, or else you got desert conditions. We're talking about everyday conditions, normal, natural atmospheric temperatures and pressures, etc. Where else do you apply this reasoning, this twisted backward reasoning, to sort of solving some sort of problem or conundrum regarding the visuals?
What I've said. There is literature, like published papers supporting what I've just said, that the refraction close to the ground is extreme in both directions.
Yeah, but that's all applied to a spinning ball Earth. But every phenomenon
no, it's not.
Every phenomenon
it was done over 800 meters, reciprocal theodolite measurements, and the ray curvature was extreme in both directions.
So where
What do
did
you mean
they,
both
when they were
directions?
doing, Rumpus said, mind of God, this is a good one, Rumpus, because if Rumpus in the chat, he might answer this. Remember, often any of us here can testify, Rumpus has said, you silly twat, you can prove the earth is flat with a theodolite, get up on the hill, point your crosshairs at the horizon, and make your necessary calculations. He said it was as simple as that. So now we find that the horizon now is not the real geometric horizon. So why would he incorporate that? Why would he incorporate it into that simple procedure if he wasn't talking about the geometric horizon when he pointed the crosshairs at the theodolite at?
When you point the crosshairs of theodolite at the horizon, it is below eye level. Why is that?
Because it's not the horizon.
It's where the sky meets the
wait a
sea,
minute. 1 second.
Not the horizon, it's the apparent horizon.
1 second, Pete. 1 second.
Massive shout out to Mason B. Great show, Ranty. Roohif is a doofus like a dodo. Thank you very much for the super chat.
Timmy Osmond, they went out, they done a wee theodolite thing, and Jesse Kozlowski set up the auto level, right? And it was below the horizon. It pointed to below the horizon, the total opposite. And that was an auto level. And that was Jesse Kozlowski, and he's tooled up. He's like the Rambo of the fucking geodetic surveyors to the ballers, man. His auto level. Listen. You're saying about the if you set up a theodolite level, the horizon will always be below the line. Well, there was an auto level, a laser auto level. An expensive proper
laser auto level.
Yeah, auto level that Jesse Kozlowski used.
Yeah, right. I'm not sure I'd be using a laser auto level to look at the horizon.
Right, but forget about the laser, but it was an auto level, meaning it automatically calibrated itself perpendicular to the ground, so it was 90 degrees, totally 90 degrees, and even Jesse Kozlowski wondered why that happened. He was even surprised, but they kept that it never got picked up by anybody, but I remember it. Right, so
over what surface was he looking?
Yeah, theodolite.
Yeah.
No, it is a point, Pete, by the way, right? It is a point because it's totally opposite from what you said.
Like everything they say, Ali, right? Like everything
but let me continue.
It's never addressed.
Yeah, but
Pete, just let him finish, dude.
We're going to address it. We're going to address it now. And also, when you're looking through a level anyway, the thickness of that little crosshair is causing there's an error margin or a tolerance. There's a tolerance level, whether it be how accurate it is, how many 100 meters or whatever, and there's always a discrepancy, and that 0.5 mil or whatever over 800 meters or a centimeter over 100 meters can cover up a part of the horizon or make so they're not that accurate. It's the same as
they are accurate. I have a video on my channel that calibrates
them. Right, to a point here. Listen, I've used them before. I know exactly about the accuracy of what theodolites and dumpies. Anyway, I'll let Pete or someone else take on. I won't get.
No, I was just going to make a point on the same thing. The other image Ranty showed earlier on with the multiple apparent horizons. Now, if you imagine that the mountain in the background wasn't there, right? Then
I am going to give a massive shout out to Paige right now, who put, Rumpus, stand on the roof of a loomed building, and I'll, Paige, will shoot at you with a sniper rifle. Is that okay? Nothing to worry about, huh? Yeah, good luck with that, Rumpus. Would you take Paige up on that? Really? Would you stand on a loomed up building and let Paige take a pop? Thanks for the super chat, Paige. Much appreciated.
Of these terms that are used and given us, right, are again associated with a spinning ball. Every one of them. Every one of them. If there's a different explanation to what's going on, then Roohif is in trouble. He's going to have to talk about how the most clear image you'll ever get is an anomaly, and the normal image then is the fuzzy, murky imagery. And that's where we're at, right? Simple as that.
My response to the auto levels, right? I have a video on my channel showing how to calibrate them and how accurate it is. And I think it was 20 arc seconds, all right? So what I can do, what I have done, you guys know Harry Baird, Fresh Look at Truth, right?
No.
Anyway, it doesn't matter. He's a flat earther from Sydney. I set up an auto level in his lounge room, pointed it at the horizon. and the horizon was like a quarter of a degree below eye level.
Yeah, it has to be, because that's not the horizon, Roohif.
It is the horizon.
No, it's the apparent horizon. You remember?
Which
I
is
just
the
said
horizon.
if you hang on. I just said did you not hear what I said about Ranty's image? Where if you took away the mountain in the background, which was creating its own mirroring, right, and you just dealt with the 3 boats or whatever they were in the foreground or in the medium ground.
Just one sec. Are we talking about Ranty's image across to?
Hang on, please. It's the same point, because you're still pointing at the horizon. You would have to identify the horizon as that visible line. You've nowhere else to point. You've nowhere else to point it ever. That apparent visible horizon. That's what you've always been pointed at. That's calculated.
Are you under the impression? Are you under the impression that
I can speak to that as well when you have the free moment. Go ahead, Roohif.
Are you under the impression, Pete, that people point an auto level and calibrate it against the horizon?
No.
Okay, good.
I'm not. But what you are doing is comparing where the apparent horizon seems to be, what you're saying is the real horizon, to this level indicator, right?
The auto level tells you level, and then there's a measurement down to the apparent horizon, which is predictable on a globe.
Right. So we've seen from blacks just to use I don't like using it. Maybe the Ranty's white elephant will soon pop on the screen for all of us to see, right? But similar images anyway. Red pill philosophies. We have a clear image of what's going on, a vast distance in the distance, right? And where's the horizon supposed to be? There's no horizon. When you point out an horizon, it's clearly beyond the target themselves, right? Or it's well beyond where the horizon should be. And you're going to come along and say, well, no, you can't trust that clear and crisp and non-sort of in general, disrupted image. You have to incorporate all manner of wonders to have you back on the ball again, right? Isn't that it?
I missed about a minute of that. I had to answer the door.
Right, maybe get Travis. Maybe let Travis answer.
Off you go. That's all. That's my point anyway. Yep. But he missed it, so it's okay.
Let's give everybody a shot here. It's not very often we get someone that's quite pleasant to talk to. So,
well,
quite pleasant.
Well, it doesn't matter. At least it's not. Hangman is quite good, and we're being civil. It's all good, man.
Okay, yeah.
That's not civil. When I was talking there, he said I was off. He wasn't listening, and he was off answering the door. You think that's civil?
Right. Okay.
Ali?
Stop crying about it. Right. Let's move on.
I'm not crying about it, man. But you think that's civil?
Yeah,
hang on, please. Do you think that's civil? First of all, I was shutting up. Do you think that's civil? And this is a liar, and you approve
No, I don't.
No, I
don't think it's civil.
Yes,
right, but let's move on, Pete. But I don't think it's civil. To answer your question, no, I don't think it is. Right, I don't agree with
Travis.
You.
Is Travis the plain truth?
Yes.
Yeah.
Yes. Okay.
Yeah.
Off you go.
Yeah, but my Skype handle is Etherband Boy.
Okay.
Just real quick on the apparent horizon. I have made so many observations with an apparent horizon where I know that what I'm looking at is not the physical water line, because I have an inferior mirage above that line, and I can see where the physical land ends and the mirage begins. If you go to the Georgia State University EDU site, Hyperphysics, they have a fantastic article on the vanishing line. The vanishing line is where the mirage begins on the physical land behind it, and then you have a mirage that exists in front of that land. But what you need to understand then is that behind that mirage is a continuing extension of the water until it reaches the physical land, but you can't see it because it's behind the mirage. So
and it confuses the observation, right?
Okay, so if you were to look at the horizon from the beach where I was at Emmawood State Beach, if you were to look out to the Anacapa Islands 20 miles away and put your theodolite on what you think is the horizon, you would be incorrect,
right?
Because the actual horizon is above it, and it can be demonstrated because there is an inferior mirage. So you cannot always understand that what you're looking at is a geometrical hard and fast location that is the actual, what you would call, horizon.
And that's exactly my
inferior
point.
mirage. The inferior mirage confuses an observation, right? It introduces uncertainty.
No, not at all.
Agreed?
Not for me. Not at all. I'm not confused by it one bit.
How do you know where the actual horizon is then with an inferior mirage?
Because you can, again, you can use the georgiastateuniversity.edu, right? It's an edu website where they have a section on hyperphysics for observations and optics, right? Where they go into mirages, they go into all of these things. No problem reading all that stuff. I mean, Jose J.G. Gonzalez was awesome when he was reading through it. He's like, yep, yeah, this is awesome. This is great stuff. Guy had no idea what he was reading. Okay, as soon as I read it, I was like, holy shit, this is exactly what I've been saying. And I'm not saying that because I'm the end-all be-all. I was just appreciative of the fact that I wasn't crazy. Okay, when you make as many observations as I have, you understand that what you're looking at with an inferior mirage is a mirage that is the obstruction that creates an apparent horizon and distorts the actual horizon above where the land stops and the mirage begins. Once you understand that dynamic, it's not difficult to decipher that when it comes up again and again and again.
Where we disagree, Travis, is what is the actual cause of, again, continuous use of the term inferior mirage. It's a baller term, out and out.
How is that a baller term?
Because all of these effects, right, are commonplace over water. How many people have seen a mirage this year in real life? You know, not many.
I can see a mirage on the bonnet of my car.
Right, but these are sort of more extreme conditions. In general, we don't get that, right? These are confined mostly to these observations over long distances, over water. So mirror image. So we agree that something is being mirrored. It's just about what the cause is. Now, to answer your question, it sort of involves asking all of us a question as well. Where is the real horizon on a flat Earth? And how would we sort of go about identifying? Just as you, and I absolutely agree, Travis, the real horizon, if you can discern it, would be behind the land. But because of the acuteness of viewing angle, it's disappearing behind this wall. It's a wall of something. It's like a mirror for all the world. When we understand we're looking many miles into the distance, we have to sort of decompose the picture. But my answer to Roohif would be, and to all of us, well, this is where sunsets come into it. This is where over open water and the calmest of conditions most perfect conditions you can imagine, this is where it's possible to identify the ultimate horizon.
Correct.
From your particular height. Hang on, please. From your particular height at 6 foot at the beach. So you're looking out, and then you can analyze the mirrored water layer, right? And you can find the mirror line. And then that line, that thin line, is the furthest it's possible to see. But you have to understand that you're looking over water. So water itself is doing the reflecting. It's the most obvious thing to consider. But Roohif, that's my answer. That's the furthest horizon possible to see. Could be many tens of miles.
Right. So you can get an auto level and point it over the ocean, right? And you're at some appreciable elevation, like Harry Baird's at, I think, 76 meters. So the calculated angle down to the horizon will be about 0.26 degrees. You can then see the sunrise, and the sun will be below your eye level. How is that possible?
You can see the sunrise from behind the island, though, obviously.
No, I'm talking about a sunrise just here in Sydney.
It's refraction.
Oh, refraction.
Yeah.
Hang on. I know what you mean. Well, here's the mirror images as well. This is the mirror layer, right? This is the cause of the inferior mirage. This is what's happening as the sun comes in from a distance. Hang on, please. It's like the sunset. This is what's happening. You get to see the reflection on the water first of all before the sun actually appears in the sky. So this is what's happening. This mirage, Travis, would you agree in general that because you have all the experience, and man, maybe you'll be famous for the black swan image. It seems to be taken over. Even the term itself is everywhere, right? But anyway, would you agree that this inferior mirage, it's a few things involved, right? Water conditions, lighting conditions, right? Zoom levels, a few other things involved, right? And then it appears. Acuteness of viewing angle is another thing. right? As we rise up, you're changing the angle between you and whatever is in the target. Let me just say in general as well, this mirrored water layer or this miraging zone can go on for many, many miles. So if an object isn't of sufficient contrast, it will disappear behind this mirage from your own perspective. You can change that and bring it back into view by raising higher because you're increasing that view. Think about it in terms of a puddle. Think about it in terms of the Bolivian salt flats, right? And how you're sort of trying to decode what you're seeing over a flat reflective surface and how it all compresses the closer you get to the apparent horizon there. So these are all things to be taken into consideration. But Roohif can't take any of these things into consideration because, let me just say, and I know I can talk, I apologize for that, but Roohif, as the sun rises, right, as you're standing at the beach over open water, as the sun rises at 6 feet, it appears to rise from behind a wall of water that begins 3 feet away from your perspective. That's what you have to hold. 3 miles away, 3 miles away from your perspective. That's madness. That's madness. And most especially when you can see mirroring from beach to beach across 15, 20 miles. You know, that's madness.
Can we, could we get...
sorry about that, off you go.
Could we get Mind of God in for a bit? See if he wants to have a chat with Roohif. I know he's tried to jump in a couple of times.
Yeah, I'm trying to jump in
Roohif, man,
as well.
Let's speak honestly, man. Let's speak plainly. We got Ali, we got people.
Yeah, you're right, Mind of God. I've been lying all this time. Let's speak honestly.
Yes, please, dude. Just no one's listening, right? The viewers are down to 0. It's just you and I.
Right.
But yeah, so okay, like this, I listened to the LK Hangout from beginning to end. You know, I guess can you first clarify your statement of more than infinite over 6? You know, I'm sure you just said that to exaggerate a bit, but like what? Like help us understand that.
Infinite over 6 radius. Okay, so not infinite refraction as in the ray of light can curve infinitely. So how can I say this? Would you be able to distinguish between a sphere with a radius of 1 trillion kilometers and a flat Earth?
A radius of a trillion. I don't know.
Very large number.
You can just keep going with your point. I'm not sure, but I'll...
Well, that is kind of the point. Is if you've got an incredibly large sphere, then from any point on the surface, and you look out, it's going to look incredibly flat. If you are on a very, very tiny sphere, like imagine if our Earth was like 500 kilometers radius, right? Mm-hmm. The hidden amount of something a few miles away would be huge, right? Because the Earth is curving away incredibly quickly with such a small radius.
Yeah, I guess that point that the ray tracer, whichever one you're citing, cannot recognize or distinguish the flatness. I personally don't know what that is, but okay, that's what you were getting at then.
As you increase the radius of a circle or a sphere, it becomes locally flatter.
Okay, fair enough.
Yep.
I see what you're saying. So
to the point where when it's flat, that is a flat Earth is equivalent to a sphere or whatever with an infinite radius.
Okay, but just spell casting. This is absolute BS.
No.
But so now let's talk about these surface rays. You're going to talk. This is the part that I think is the voodoo that none of us like. How can you have a ray?
Can you turn up his volume?
Yeah. Can you hear me?
It's difficult, but yeah.
The surface rays, the K equals 1.
Yep.
Like it's tight to the surface. You're talking about a gradient that doesn't exist. Like, just help us understand that. There's not much variation when you're talking about being that close to the surface and traveling such a far distance, 8, 9, 10 miles. Why do you guys keep saying gradient, and all that? Help us understand.
Sorry, is the question that you deny a density gradient?
Yes, close to the surface, because it's K equals 1, right? Or you guys even said it's higher than K equals 1. Right?
K equals 1 is causing rays to bend at the same rate as the curvature of the Earth.
Exactly.
And therefore, it's equivalent to infinite over 6R as well.
Yeah, they're tight to the Earth. They're traveling over the surface of the Earth if you were to follow them, right?
Yeah, at the same rate of curvature as the Earth. Yeah, that's K equals 1. Yep.
So the derivative, the density gradient matches the derivative of the surface of the Earth. So that direction change is happening all the time, and it just happens to match the Earth curvature, right? That's another way to word it.
That's K equals 1. Yeah.
Right. So that's the issue, man. You're going to require a major change in those rays when the density gradient is not, there isn't really one. It's a fairly consistent environment over the top of the surface of the Earth. So how do you...
No, density gradient's been measured for decades.
No, but if a ray is traveling along a surface for that many miles, what's changing? What's causing that change in density?
It's causing... Are you talking about a change in density from point A to point B rather than a vertical? No,
because
the changes...
Because it's tightly coupled to the Earth.
Yeah, just real quick. Yeah, just real quick.
Refraction?
This is very crucial. This point is very crucial.
Yeah, what causes refraction is the vertical density gradient, not the gradient from a point on the surface to another point on the surface.
Right,
That's
right.
irrelevant.
And so now again, you get rid of perspective again. Brilliant.
No,
yeah.
there is no vertical. We're talking about a 1 or 2 or 3 foot chamber or a corridor. So like you don't think that there's a gradient in that range, right? On the surface.
Vertical or horizontal gradient?
Well, definitely not horizontal. I hope that's what I'm leading towards.
Do we agree that a horizontal gradient is irrelevant to refraction?
Well, there isn't one. There wouldn't be, because it's so close to the surface of the
There is.
water.
I mean, there are actually small pressure differences between one place and another one, right? And temperature differences, right?
Yeah, we were. So we were trying to tell Rumpus that, but he didn't like that. But yes, we would agree with that for sure.
Is that Roohif, is that established principles, infinite over 6R? Is that an established sort of understanding among scholars? And
they wouldn't phrase that way, but it's equivalent to the K equals 1, which they would phrase that way.
So Roohif, Rumpus just said in the chat, there is no change of density for circulating rays. The ray remains in the same elevation. So that's our issue. Like, help us. We're more on the math side, me, Ali, and Pete, and Ranty. If that is the case, and he just literally typed that, what is causing this density change, which is changing the direction? Just on
the back of that question, mind of God, when you incorporate infinite into anything, it's either going to go to infinity or 1 over infinity into nothing. So you have the capability. That's a variable in a sense. You can make that to whatever degree you so choose, right?
Well, no, that's what allows it. That's what allowed the circular rays to go around the entire Earth, because it's constantly able to change direction. That's what he means.
Yeah, and the density gradient is causing it to change at the same rate as the curvature. It's kind of like an orbit, really. Like, you've got a light ray in orbit. You could probably say it that way.
I like that word, dude. Yes, let's call it that, because it sounds ridiculous.
Light ray in orbit.
Yeah, it's like we have our imaginations turned on to imagine all of this, right?
Yeah.
But wait, so just intuition. We know that the Earth is flat, but just help us. Like, what could motivate that ray to do that?
Rays don't have motivation, right?
A stiff joint beforehand.
Well, no, it's either temperature, like Rumpus was saying in that presentation. Temperature motivates pressure, motivates a density change, right?
Yeah.
That's the quote sequence of events. So if we're close and tightly coupled to the Earth, which he just typed in the chat, and I agree with, and it's obvious, it's a surface ray that has to go tight to the Earth and then reach maybe a 3 or 4 or 5 foot camera. So it's not going 10, 20, 30 feet above the surface of the Earth, right? That's obvious.
Well, if you've got a perfectly uniform density gradient, no, it'll stay exactly in that duct.
Right. Yeah, exactly. So, there's not much wiggle room for anything in that corridor to change its direction. So that's the part that either you
density gradient changes the direction.
Yeah, but
why did you ask him about a 30 million mile across, a trillion mile across planet? Would you know the difference between that and flat? Why did you ask him that?
Just let him
question?
finish this point. Just let him. You guys are saying a density gradient, but in another message, Rumpus is saying that there is no change in density. So that's the part that we don't understand.
It's being kept in the same layer, because it's curving. The density gradient is still causing it to curve.
Yeah, but he's saying there is no change of density for circulating rays.
Correct. It's staying at the same level. Yes.
Okay, so what's creating the gradient? Because a gradient or a derivative is the only thing that's going to cause that light to move. So there's nothing there.
The density gradient is causing it to bend.
No,
are you denying? Quick to clarify. Are you denying that there's a density gradient in the atmosphere?
Well, no. He's just saying in this message, and I agree with him, that first the K equals 1. I'm not talking about all the other rays. I'm talking about the surface rays that created that ability for that platforms, for that horizon. I'm talking about that specific instance. I'm not debating higher up that there are layers. No one would argue that. I'm focusing on
there's even layers.
Talking about the circular rays.
Roohif, when you say a density gradient, what is it a density gradient of? Of what?
Yeah.
The optical density of the air.
The optical density of the air. Okay, so can you Can you quantify that for me? Like, what is that? Can you show me a piece of that?
Can I show you air? Is that a joke?
I'm trying to understand your terms. Okay, don't think that I'm being smart with you. I'm asking you to help me understand what you're saying. Okay.
As in what components go into changing the density of air and therefore the refractive index?
Yes.
Sure. Pressure, temperature, humidity, and CO2 content are the main four.
So,
and there's been enormous.
Rumpus just said the ray remains at the same elevation, therefore at the same density. I agree with him up to this point.
Yes.
But there is a density gradient. That's the part that we don't like. You're slipping that in. How? How can something...
I asked you before, do you deny there's a density gradient?
It's on an equi density
layer.
Yes,
I
do. Right?
Sorry, an echoey?
It's on an echo, or it's on an equi constant density layer that this ray is traveling on, right?
Yep.
Okay. So then now help us understand, where's the gradient coming into that factor? Like, how is that infused into that when it's traveling, like I said, in a constant density channel?
The gradient's causing it to curve. If there was no gradient, it would break out of that equal elevation.
Right. Okay, hold on.
Yeah.
Go ahead.
No, I was just going to say, so there's another layer above it that's pushing it down constantly?
No, the density gradient is causing it to curve at the same rate as the Earth.
Mind of God, 1 second. You've got to imagine that the light's travelling in a duct. Because it's homogeneous. Yeah, I know that's what you're saying. But you've got to imagine it's in a duct is a three-dimensional. So when they talk about geometrics, it's only lines. It hasn't got any dimensions to it. So it would have to be a duct that the whole light...
It is a duct, Ali, and I agree. It's just, we understand the derivative.
Yeah, no, but it shouldn't refract. Listen, it shouldn't refract like that. Then that's the point you're making, because there's nothing making the light bend, because it's going through a homogeneous.
Makes the light bend.
No, but it's going through a homogeneous duct.
No, it has to. Not homogeneous. Ducts are not homogeneous.
Yeah, you just said
no, but it would have to. I know they're not. But that's the point, they're not. But the light for that image to come up, it would have to. That's the whole point the mind of God's making. Anyway, just had to get that bit.
Yeah, there is no gradient, man. Like, I think just, dude, come to our team, man. We got a lot of nice people. We have weird people, but you don't need to push.
You're denying there's a gradient.
Yeah, we are nice.
You're telling me there is one, but not describing it physically. How is there one?
Well, can you go to the top of Everest and breathe normally?
We're talking about surface rays, though, man. We're talking about K=1 surface rays that allowed that platform image to even manifest.
Yeah, but
I have no issues.
We have, but the gradient, there is gradients, but the gradient is above and below whatever duct that the light's traveling through. Because if it went into the other gradient, it would refract even more. But it doesn't. For the light to come to you, it has to go through a duct. If you want it to describe it the way it happens as it comes over the curvature of the Earth, it has to travel.
Do you agree that a duct has a density gradient in it, or do you think that it is?
No, because you just said it's constant. You guys both.
Yeah, exactly.
No.
Exactly. Well, then it wouldn't happen that. Then it would maybe go into a lower layer. The precision, it's an idealized imagination of geometric optics. That's all it is. And that's all you're saying, but you can't see it for yourself. But the mind of God explains it perfect.
Yeah. But Roohif, just think about this, right? Think 1 second. Roohif, just think about this. The ray, along the ray, there's going to be a derivative change because it's traveling over the surface of the Earth. So that is needed in order for it to move. And so now you're saying what's allowing that to happen are new densities, new environment that it's around. And so that's the part that's needed. And I don't think you guys are explaining it.
Not new densities.
Yeah, it has to be, because that's the only thing that can motivate a derivative change of that ray to change direction over the Earth, the curved Earth. So derivative implies density, right? If you have a new derivative, new gradient, new direction, you need a new density to make that happen, right?
I'll say this very clearly.
And it has to be a
density gradient is constant.
And it has to be homogeneous.
Density gradient is constant, which causes constant curvature of the ray.
No,
it's
but
not the case that the density is gradient. The density is constant.
This is a bad night for you, because you run into people who know what that means. So we don't just give you that because you say it.
I think you're giving yourself a bit of a...
No, but we know what that means. We know that a gradient or a derivative or something means something's changing. So if you're telling me there's a density gradient, that means there's a density, there's layers, there's a change that's happening constantly. We need to understand how is that happening along the ray, along its journey to the observer.
Are you talking about like at a molecular level or something?
No, I'm just talking, just what is the environment that it's around, like, that is motivating it to do that. We need to know that physically, not at the atom or molecular level.
I've said the same thing like 5 times now. It is a density gradient causing it to curve.
Yeah, but we need to know
how big is that gradient? How big is that duct?
It's a K = 1 duct.
How big is it?
What do you mean? How wide? It can be any width.
Yeah. So again, you guys, okay, it's very difficult not to lambast you guys because you are presupposing a sphere, right? You're presupposing that light bends over the surface of the Earth. Okay, but you cannot prove that. You cannot demonstrate that. All you can do. Can you
prove the flat Earth?
Okay.
No, not yet.
Don't reverse the burden on me. What I'm saying is the claims that you are making, you can only show us in diagrams. You cannot take any pictures, and I've asked Rumpus, I've asked numerous ballers to show me in my pictures the shenanigans that you're talking about, Roohif. You can't do it. All you can say is...
You guys are very confused about this circulating rays, I got to say.
Yeah, we are, because that's the issue, that we cannot be a baller because we cannot understand how a ray will move just because you verbally say that there's a density gradient. That doesn't mean that there is one. I could say there's a density gradient in my apartment right now, but until I tell you what's causing it. Yeah, but I could either measure it, I could tell you exactly what's causing it. Is it just the height that you're... The only issue, you don't have that much wiggle room because, again, you're saying this is along the surface, so you don't really have that much room, literally, to work with, because we're talking about 1 or 2 or 3 feet above the surface of the water for 10 miles, so you don't have much wiggle room.
Right, so let me ask you this question real quick, Roohif. So from what I can remember, you just referred to a constant. Is that correct?
I was trying to make a distinction between a constant density and a constant density gradient. They are very different things.
Okay, great. Would you mind doing that one more time, please?
Okay, so a ducting ray, so one that follows the curvature of the Earth, is in a constant density gradient, not a constant density. If it was a constant density, it would escape the duct.
And how do you know this?
Yeah,
because I know how refraction works.
No, you're making the density gradient match the curvature of the Earth, and we know what you're doing.
Do you think there's no science backing up refraction?
But dude, just admit it and we can move on, man. Honestly, no hard feelings. It's flat.
There's loads of science, but the wrong context is there.
Yeah, that's correct.
Yeah, but if it escapes the so-called duct, then it's going to refract anyway. Then it would stop curving. And then what it would have to do, wait a minute, then it would have to get drawn back to the heavier, the more denser gradient, and then refract again all the way for 9 point something miles to your eye. That's what we are meant to believe.
Ali, that's a good point, because it has to stay tight to the surface or else it won't make it.
Yeah, exactly.
Yeah, no, can't do that. We know that.
Yeah.
Well, Roohif, why are you on that team, man? Just stop. Rumpus, like we have some nice people on our team.
I'm on this team because I understand refraction. You guys think this
has no
science?
Like you're flogging a dead Rumpus.
You're flogging a dead Roohif. Nice one, Pete.
But when you say density gradient, you're implying density variation, right?
Roohif.
What, sorry?
If you say density gradient, you're implying a density change.
That's a meme, Pete. Sorry.
Okay, great. So let me ask you this question real quick, Roohif. Maybe I'm going to switch tactics here.
Yeah.
Would you be willing to take 5 images that I have given to you, and I'll give you my data? Okay. The only thing that I don't have is the temperature and all that stuff that you guys are interested in, because I don't really care. But what I would like to do is find someone who can crunch your numbers, do all the math you want, and tell me what my image will look like due to refraction. I don't want you to tell me that I don't want you to tell me that there's an inferior mirage. I don't want you to tell me, that there's going to be some mild distortion, or there's going to be a superior mirage. That's not what I'm asking. I'm asking you to tell me what my image will look like through that refraction.
All right. How close to the surface are you?
5.5 feet.
Okay. I don't give a shit about your observations.
Okay, great. So I'm curious, how high do you have to be to give a crap about observations?
The higher the better. At least 30 meters. At least.
Okay. Hold on real quick. So 30 meters is like 100 feet?
Yep. So at least that high.
Great. Okay, great. So do you know how high? I'm just curious. I'm not trying to catch you out. Just curious. Soundly's towers. How high was that observation?
I think you said the 15th floor or something. So it's at 50 meters or so.
50. Okay, so that's less than your standard. Or no, it's above. It's above.
No, it's more. Yeah. Like the higher the better. Like something like Canigou, the dude was at 320 meters, right?
Yeah.
And there's 2,500 meters missing.
Yeah. What about
Yeah.
What about the wind turbines? How high was that observation?
Which wind turbine observation?
The one that Rumpus loves to harp on about. Those wind turbines.
No idea. Okay. I often see wind turbines underwater, so there's that.
Yeah. Right. Yeah. So I mean, are there any observations that you have looked at and you're like, yeah, I could totally see that's curvature?
Canigou. I just said Canigou.
No. I mean, like with freighters or anything like that. Anything like with freighters.
With ships on the horizon.
Yeah.
Yeah, I take my auto level out and look at ships on the horizon. They're below eye level.
And where are you at when you make those observations?
What's the height? 244 feet. What's that? 70 meters something.
Just curious.
Yeah. Yeah. Get high so you don't have to deal with much inferior miraging or extreme refraction either way.
Yeah, it really depends on what the distance of your object is. It doesn't matter if you increase your elevation. I mean, if your observation is going to increase in distance, you're still going to have an atmospheric distortion. It doesn't. I mean, doesn't always
with Canigou, right? So Canigou, the dude's at 320 meters, looking across to the mountain. I think it's like 260 kilometers or something. Like at some point, that ray will get close to the surface, right? So there is a tiny inferior mirage. But there's still 2,500 meters of the mountain missing.
Right, that's behind the mirage. That? Yeah, that's behind the mirage.
No,
yes,
the mirage is the mirage is tiny.
No, right, but you're not taking into account.
Yes, right.
You're not taking into account perspective, distance, and the aether band. You're not taking
absolutely taking into account perspective.
And distance and the aether band. I said 3 variables, Roohif, not just one.
What? I don't even know what the aether band is, by the way.
Okay, yeah, you do. Yeah, you do.
No, I just said I don't, so.
You do, because it's
awesome.
the air. It's the air.
Awesome,
air.
yeah.
So the air.
Yeah.
I'm looking through the air. I'm not taking into account the air. Okay.
That's correct. Yeah. So that's what I've said from the beginning. The only obstruction always is due to the conditions of the air. It's never due to earth curve. So when you have distortion, you have distortion because of refraction. You have refraction because of the conditions of the air. Now, whether or not there's a mirrored image, it depends on what's going on. But
forget about the vast ocean you might be looking out over, Travis. Come on, man.
Sorry.
Forget about the vast ocean, the surface, right, which is most important, that we might be looking out over. I mean, that has to come into it as well. How far can we actually see to the real horizon? How do we identify the real horizon? Is it only when there's contrast that we can see it? Otherwise, this mirrored layer might reflect the sky in the background. So don't mention that. Just put it down to the air. And just by the way, I'm going to head off as well because I know conversations like this get nowhere. But my last point would be, well, the air is said to be composed of 50 million billion tons of water in its vapor phase, right? So water is reflective in all its form. That's all I'd say. So listen, I'm going to say goodnight. Getting over it, Roohif. Once again, you won't admit anything. And what can you do?
Nice one,
Good night, Pete.
Good night. Take it easy, buddy.
All right, Travis, can you see my screen?
Yeah.
Yep.
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 Yes.
Yep. Yep.
Yes.
Okay.
Yes, we can.
Right.
Yes.
What is obstructing the 2,500 meters of mountain that's missing?
Well, I'd be
Earth curve.
curious as to hold on. I'd be curious as to your measurements to determine that that's the actual amount missing.
Sure, let's do that. This is going to be difficult to do without.
No.
Anyway.
Just hold on. Just real quick. You do understand the absolute ridiculousness of the task that you're performing. That is.
Do I understand the ridiculousness of the task?
Are assuming that you can scale that proportionally. There's no way.
This is perspective, Travis.
Okay,
this is perspective.
So what's the claim here? The claim is that you want to see how much is missing rather than the fact that we can actually see it.
Yeah, well, we agree there's refraction there, right, don't we?
No, that's not refraction, that's looming.
This depends on your definition, but sure.
Yeah, that would be
let's
looming.
work out.
We do not agree that there's looming.
Again, depends on definition. We'll argue about that later.
We don't believe that things can be lifted up from beyond any kind of curvature.
Okay. Can someone bring up the angular size calculator? It's 1728.org or something.
I can go to it. What's it called?
Type in angular size calculator and there'll be a link, and the website's called 1728.org.
Okay, well, I'll tell you what, Roohif, if you can demonstrate looming or bending up from beyond the Earth curvature, then we can get into how much is missing from this mountain.
We'll do how much is missing first, and then we'll get to looming. We did that the other night.
Ranty's a tough negotiator, man.
That's fine.
Let's just agree that geometry would suggest that you shouldn't see any of this mountain. Yes.
Yes, correct.
Okay, so the only reason so we see it because it's there. You say it's loom, so you need to prove, which is what I've been asking for 3 years, looming.
Yep, and I showed you the oil platforms the other day.
That's not proving looming. Harry's. That's not a proof of looming.
What is it then? Why are they not?
Curvy
why are they not in the same relative positions?
That isn't the proof of looming.
The horizon was raised, and they are in different relative positions. What else would you accept?
The horizon was raised.
Yes.
Is it this photograph?
Is
it this photograph of the sun or something? Is that what you presenting as Canigoo Peak?
Yes. So this is from.
Well, wait a minute. I'm wondering, right, because the sun's behind that mountain. So you're telling us there's a shadow being projected. The light from the shadow is being projected over the horizon. That's fascinating.
Yeah, we can see the silhouette from 260.
Yeah, but that side of the mountain wouldn't be illuminated. So you're telling us an object that's not illuminated will be seen, that the light that comes from a shadow actually gets projected over the curve. Oh, well, the lack of light, but you're still telling us if that's looming. That's obviously that's not an illuminated object. It's the back end of that.
Yeah, it's backlit.
No, wait a minute. But you're telling us a shadow. Yeah, I know what you're saying. I know exactly what you're saying. But he's telling us a shadow. A shadow is the lack of light. Now he's telling us that the lack of that light there, a silhouette is travelling all the way, however far away it is, up and presenting itself on the horizon. Are you joking? Are you serious?
I'm struggling to understand what your point is.
How can you see something that's not illuminated? And you're trying to tell us it's there on the horizon.
You're asking me to explain what a shadow is?
No, but but what is a shadow? It's not light, is it?
Exactly.
It's the lack of light. And you're telling us, wait a minute, you're telling me that lack of light, that light, that light beam that doesn't exist because it's illuminating the behind the object, this light that doesn't exist is coming around the curvature and presenting itself on the horizon.
So confused.
So
confused right now.
Yeah.
No, Ali, I'll explain it to him. Ali, I'll explain it to him. I agree with what you're saying. So he's saying, imagine that thing is deep behind the Earth curve, Roohif, for a moment, right? And then there's light rays behind it, going through it, right? Pushing behind it and then presenting this image in front of us that you see. His point is that black that you see in front of the sun is actually restricting light, in fact, to come over the curve. So right. now you're telling. Yeah. So okay. Maybe Ali can confirm that's what he means. But yeah, it's the absence.
Yeah, that's what I
blockage of
mean.
light
It's
that
a
you-
shadow. It's exactly that. It's a shadow that's getting projected round the curvature of the Earth.
Yeah. Exactly.
In contrast
shadow
to
is a
the
lack of
light from
light.
the sun
But
that is
Ali-
curving around, right?
Ali, he would just say it's the outline, and I don't necessarily agree, but that's probably what they would say.
Yeah, I know, but that would also mean that the bottom of the sun's also refracting, and you can even see the sunlight. Wait a minute, you can even see the sunlight underneath that mountain.
Yeah,
that's an inferior mirage.
You understand that? So it's that's an inferior mirage. But how's it reflecting the bottom from underneath? That light can't possibly be coming over the top of that mountain. The angle of that light would have to come over to shine over the top of that. That sun would have to be right next to that mountain there to cause that light to come in front of that, because it would have to be taller. And remember, that's 93 million miles away. So the angle that the light would be coming in, you wouldn't get it over the top of the mountain. You'd have the shadow. You'd have the shadow of the mountain there, if it was a true projection.
Oh man, this is a struggle.
Yeah.
All right, so let's not forget my challenge to Roohif again. So my comment is that I do not believe you would be able to verify your math. You're going to crunch your numbers. You're going to say that, you're going to get your measurement of how big the mountain is, how far away it is, and so this should be the angular size.
Yep.
I believe the only thing that you're going to be able to do is say, yep, that image is what the numbers are. No. Prove that image matches. That's all you can do is declare. You cannot verify that what
we're going to demonstrate. We're going to demonstrate that there's about 2,400, 2,500 meters missing of this mountain, using angular size, by the way, kiddies.
I know.
But can I just say, you're literally showing an impossible image on a globe, and then trying to present it as a globe proof.
How is it impossible on a globe?
Because we're seeing it, and we shouldn't see it. You're presenting something we shouldn't see, and then they're going to try and present it as a globe proof.
Yeah.
I mean,
I know you guys are trying to derail this, but
no, it's the truth. We shouldn't see it. It's the end of that's it. That's it. That shouldn't be there on your model. That's it. And then we see it.
It should, and you know this, Ranty.
You bring up an image that shows that we're seeing something that we shouldn't on your model, and now you're going to tell us that this is proof of your model.
Our model includes refraction, therefore we should see it.
You're now going to say to us that this is proof of your model, when it shouldn't be there.
I'm asking you guys why. Why is that? What is the physical obstruction between the bottom 2,500 meters?
There is no physical obstruction. It's a mirage. There is no physical obstruction, Roohif.
What are we looking at? What is that? Not water that we're looking at? Is that not the horizon of water?
No. Okay, listen.
That's not water.
Okay, wow. Listen to me, please. It's like you don't watch my channel. Okay,
I don't.
Okay, well that's obvious. Listen to me, please. Okay. I have made this absolutely clear on my channel that is the aether band. That is not water. Okay, that is the air. It is a mirage. It is the obstruction, and it will hide however much amount of the object it can hide. You can't quantify it. You can't say that the mirage is going to hide this much of the mountain. You can say geometrically how much your maths are going to show, and that's my point. My point is you can show me, or you can tell me geometrically what should be hidden. But when refraction comes into place, you can't tell me what the image is going to look like, because you don't know how to understand the aether band that way. But
I think it's just fucking gibberish, Travis, to be honest.
Yeah, I know you do, and that's too bad. I'm just going to keep singing the same song. But that that amount of light that you see there at the base of the mountain is a mirage, and just simply because you can pinpoint with pixels, right? You can say, I don't even know what a pixel is in terms of its size. But let's just say, for instance, that light at the bottom of the mountain, just for instance, is 5 pixels, right? Let's just say that. That doesn't mean that's where the mirage stops and ends. Okay? That's why you don't know what you're talking about. The mirage could be 4 or 5 times bigger than that, and you just can't see the demarcations. So it is hiding more of the mountain than you are aware of.
Plain truth. Let's just let him go with his. This is his argument, so let's go with it. So I got the website open, Roohif, that you want.
The angular size calculator.
Yeah,
right.
Exactly as you said. So there's 4
boxes. Does everyone agree that the sun has an angular size of 0.5 degrees?
No, sir. Just don't ask for agreement. We'll just go through your argument, man. 93 million miles away, man. We weren't born yesterday, dude. But
does it have an angular size of half a degree? Yes or no?
Absolutely not.
Have you measured it?
No.
Oh, just get on with it. Forget that. Do what the mind of God said about agree, and do you agree this Socratic method? Just get your argument.
Yeah.
All right. Can you see my screen at the top left? And I've drawn a rectangle against the sun, and it says 227 pixels wide and 48 high. Yep.
I don't see anything changing on the screen. I just
doesn't matter.
see this.
Okay.
Yeah, I'll go for that. I'll go for that. Yep.
Right.
I'll trust you. I'll trust you.
The sun is 227 pixels wide, and that equates to 0.50 degrees. Okay.
Oh, I see what you're doing now. Okay.
Yep. All right. Now, how high? This is Canigou here. If you can see me pointing at the top peak.
Yeah.
Going down to the horizon, I'm going to say that is 42 pixels high. All right.
Yeah.
All right. So let me just grab a calculator as well. 42 divided by 227 times 0.5. So we agree that the height of Canigou, what we can see of Canigou, is about 0.09 degrees angular size. Does everyone understand how I did that?
No, man, but just make it quick, dude.
I understand where you're going. Carry on.
How far away is this thing?
It's angular size. That's all it is.
263 kilometers, I think.
160 miles. 160 miles.
No, 263 kilometers. I'm pretty sure.
And about 1,000-foot elevation, right? I remember.
This one, I'm not sure this is the same photo that I usually use, but it'll be somewhere around that. It doesn't really matter. All right, so if the width of the sun is half a degree, we can scale it against the height of the mountain, or the height of the visible mountain, and say it's about 1/10 of a degree. Okay, just by using the scale. Yep.
Sure.
All right. Who has
I
the
wouldn't say
angular
a tenth. I wouldn't say a tenth. No.
It's a fifth because it's 0.5 versus 0.1.
It's a fifth.
0.5 versus 0.1. Right. Okay.
Yeah, but not a tenth. A fifth.
1/10 of a degree. 1/10 of a degree.
All right. Yep. Going. Right.
Yeah,
going.
Okay. Good. All right. Whoever has the angular size calculator, I want you to plug in a distance of 263 kilometers and an angular size of 0.09 degrees.
So it's giving me 3 options. Do you want to solve for angle, distance, or size? So which one of those?
Size.
3?
I want to click the size button, and then it'll ask you to put in the distance and the angle.
Yeah. So
and the distance is 263 kilometers. So 263,000.
Yep.
And then an angular size of 0.09.
Okay. 413.
413 meters. Okay, how tall is Canigou?
Let's see.
So let me just get this right. You're saying that is only 413 meters.
Yeah, that's what we can see of Canigou.
Hold on. So from 160 miles away, something that is almost probably around about a fifth the size of the sun in appearance is how much? How many meters again? From 160 miles?
413 meters.
So you think we can see 413 meters at 160 miles?
The height of what we can see is 413 meters, yes.
You think we can see something that is 2.5 times the size of Blackpool Tower at 160 miles away?
Yes.
That's crazy, dude.
No.
Are you kidding, guys?
Well, I mean, I don't know for sure, but it sounds shady.
That sounds, I mean...
Are you saying it's too small to see?
I'm saying that there's no way that is just 400 meters of that mountain.
Well, if you guys deny perspective, I hate to throw that word at you, but you guys are denying perspective if you don't agree with that.
Whoa, don't get me, man.
Hold on
No,
again.
what's the height? What's the height of the mountain? What is the height of the mountain then?
It's
No,
about
hold on
2,800.
real quick. Listen, hold on real quick. There's two other variables that you are not taking into consideration. Well, you are taking into consideration the second one. But the third variable, Roohif, you aren't going to consider, okay? Because it's going to do damage to your supposition. And that is, you have no idea how refraction has distorted that image. You're thinking that it's just geometrically there. It's just to scale. It's perfect. It's
That's
not.
not perfectly to scale. It's got an inferior mirage.
You don't know how big that inferior mirage is, Roohif.
I can see it on the screen how big it is. It's
No,
like 4 or 5
you
pixels.
see a portion. You see a portion of it.
I have rendered the actual elevation data and overlaid it onto not this particular image, but a similar image, and it matches. Therefore, no distortion.
Okay, that's okay. That I would challenge that. Okay, but first of all,
I've got like
let me-
3 videos on my channel of it. So
okay, well, just like you, I haven't watched your stuff. Okay, so
you're always the first to comment though.
It's getting nasty.
okay, so
I'm having
listen,
fun, come on.
listen, hold on, real quick. What do you think is the inferior mirage?
Light rays curving upwards.
No. In this image, what is the inferior mirage that you can see?
What do you mean? What is it? I don't understand the question. It's blocking a little bit of the mountain.
Okay, well,
Okay.
I have 2 questions, but I want to do it after you finish this line of questioning because I'm trying to get a
Okay.
word in and you're not giving me a chance. So.
Yeah, okay. All right, I'm not really sure if anybody knows what I'm trying to ask. I'm just asking you, as you look at this image, you see an inferior mirage, right?
Yes.
Can you describe
Yep.
what you see? What is it that you see that you think is an inferior mirage?
A reflection of the sun underneath the mountain, which is obviously impossible.
Okay, so could it be that there is more of an inferior mirage that you are not able to detect?
Could there be?
Yes.
I'm not seeing any other mirroring though.
Okay. Could there be an other dimension
Oh dear.
of the inferior mirage that you are not able to detect with your naked eye right now?
Oh, you can claim infinitely many crazy things, Travis.
No, Roohif, listen. I have GeorgiaStateUniversity.edu as a reference. I can show you and demonstrate to you with my own data that an inferior mirage isn't simply the sky being mirrored. It includes...
Sure. I'll read it. Like, feed it to me on Skype and I'll read it.
Okay. It includes as well the landmass behind it to a certain extent. What I'm suggesting to you is, and I just want you to just consider this as a possibility, that the inferior mirage is more expansive than simply the light that you think is exclusively the inferior mirage. I yield the floor.
I will
Ranty.
consider anything possible that is not logically impossible. Do I think it's likely? No, it sounds like
yet
fucking
you're a
gibberish.
baller. That's really ironic.
Well, that's actually let's talk about my challenge for a second, right? Everyone knows my challenge. I've offered up to $10 million for a glober and a flat earther to present arguments to a neutral third party, and whoever convinces the neutral third party, winner takes all, right? So it's all about
10 million? What the
Yeah.
heck?
Yeah, Roohif's rich. In case you
it's
didn't
all
know,
about the unreasonable burden of proof that flat earthers put up to prove the globe to me, prove curvature, and we all say, here is obvious evidence of curvature, but then it comes down to the flurfers' burden of proof as to what they will accept as evidence, and they obviously have some ridiculously high burden of proof and will never be convinced.
Now
So
you're
that was the
acting
reason
like, oi, listen, less of the insults, man. We've been nice to you. Don't start flinging about flurfers. You've already had a free pass there when you insulted us before. Please don't do that.
When did I
Don't
insult
lower
you?
yourself
Roohif, if you start
I stuck
if
up
you start
for you
doing
earlier
that,
on, mate. I stuck up for
Ali
you
B
earlier
and
on.
Okay,
Ali,
listen.
me and I are going to start
Disrespecting every
talking
single
about
one is.
density gradients. Man.
Okay, listen. Before
We're going
you
to start bringing up density gradients again.
right, before you guys
Intros.
get into this, I've just got two questions. The first
Yep.
one's actually from somebody in the chat who's asked this question several times, so it should be just pretty much a yes or a no answer. Please, can you ask Roohif if you can determine the distance to the horizon using the angular diffraction limit of the human eye?
The angular diffraction limit.
Yes.
That is like a nonsensical question.
Okay. Right.
Like, I know what the diffraction
to-
limit is, and I know how you guys misapply it. Actually, sorry, getting back a second. Where did I offend you guys?
No, just don't do the flurfers and stuff, man. We all have degrees.
That's the
we
thing.
know
A
what's
bit of
going on, dude.
respect.
Yeah.
A bit of respect in that.
Chill out with that.
You've been in the poisoned well too long in your bring across. We've been totally nice to you, man. Come across,
Okay.
we're nice
Believers.
people.
So,
People that believe the flat Earth.
hold
Right,
on.
thank
I'm
you.
fine with that.
That's it.
So my second thing to show you guys is this image here. So Roohif, can you take a look at my screen now? You can see that I'm sharing, yeah?
Yep.
So what part of what we see here would you say is the
Hang on.
actual...
I've got to stop sharing my screen. One sec.
Okay.
Why can't I stop sharing it?
I think I've already cut you off by sharing
Have
my
you?
screen. Yeah, I believe so.
All right. Boom, boom. All right. Fuck. Hold on. There we go. All right. So, yeah, what's the question?
So I took this image of the sun. Can you tell me which part of this sun is the actual sun?
Are you asking, do I believe it's refracted?
Well, I'm asking you, if you look at this image here, which part of would you say that this part on the left here is part of the sun? Or would you say that that's more of the kind of the light that's coming from the sun and not the actual sun? Would you
I think it's the actual sun. It's obviously distorted though, right?
Would you think that this is the entire sun from left to right? And not just this part here?
I'd say it's the entire sun. Well, I mean, at least half the sun, sorry.
Okay, so that's your opinion. Fair enough. Okay, so let me compare the two images. This is your one, yeah?
Yeah.
This is your image.
Yep.
This is my image. And I have lots more of these type of images. See, as flat earthers, we know that the light from the sun expands when it actually going through the atmosphere before it actually hits your eye. So,
hang on a sec.
As flat earthers, we know that this is more or less likely the real sun in the distance, a very much smaller apparent sun, and what we've got here is the apparent sun is much bigger. That's why it always looks bigger at sunset. That's why the moon looks bigger at moonrise. If you actually can Google this effect.
So hang on, you're saying the yellow bit at the top is the sun and the red stuff is not?
Yeah, that's the light. That's the light from the sun.
Wow.
And that's the actual sun, just going further away. I have a whole bunch of images on this particular. Here's another one. You can actually see the sky above is very bright here. You can see the real sun here, much smaller, and you can see the light from the sun actually expanding. This sun looked massive on the horizon when I was filming it. I've got lots of these types of images. Here's another one, another one, another one, another one. So when we go back to your image here, this one, and you said to us work out the angular size of it, how do you know what part of what we're looking at is the sun? How do you know that what we're seeing here is the actual sun? How do you not know that that's just the light from the sun and the real sun is much further away but smaller and behind this light?
Are we talking like glare or something? Is that what you're getting at?
Yeah, if you was to look at a lighthouse.
Yeah, I'm talking about.
If you look at a lighthouse, when a lighthouse flashes and you're looking into it, imagine you was in the line of sight of the lighthouse, right? Suddenly everything's filled up, but it could be coming from just a small couple of feet.
Right. Put a solar filter on, and it's still half a degree wide. The end.
Have you got a solar filter to put on this?
I have a solar filter I can put on my camera and take a photo of the sunrise, yes.
Was a solar filter applied on this image?
No.
Right, so how do you know where the real sun is?
How do I know where the real sun is? It's there.
Yeah.
We see it because it's
No,
there,
you
Ranty.
see,
Isn't that
you
your
see,
catchphrase?
you see light from the sun. It doesn't demonstrate that you're actually looking at the sun itself,
Yeah.
the actual physical
You don't
object.
get glare. You don't get glare when it's like that close to the horizon.
How do you know? What about this?
Because
This was close. Hang on, wait a minute.
Done this,
This
right?
was close
Wolfie's
to
done
the.
this.
What's that got to do with it?
That's absolutely false, Glenn. That is not true.
Wolfie,
This was
has
on the
done
horizon. This was on the horizon.
Yeah.
I've done this. I've got a whole bunch of images.
You put a solar filter on and it's still half a degree.
Was a solar filter put on this image at the top here on this day?
No, but Wolfie has a video where he puts a solar filter on and the sun is half a degree.
So how can you say that this is the real size of the sun on this day if it wasn't filmed through a filter?
Because the sun is half a degree
it's a very, if you can't demonstrate that, you have to concede that if there was no solar filter on this day, you cannot make accurate measurements or take accurate measurements. You cannot take accurate measurements. I'm sorry, Rumpus, but that's just the way it is.
There's no glare in this image.
You don't know what the camera was.
Now he's making fun of you by calling you the Rumpus. So that's really
that's offensive, Ranty. Come on.
So ultimately, all I'm going to say is that this is inconclusive, but what isn't inconclusive is we actually see this mountain. We see it, shouldn't be on your model. You've got to demonstrate looming, which you cannot. You've also got to try and find out how much is missing from this mountain, prove that this sun is all of the sun that we're seeing and not just something like this, where the real sun is further behind it and we're just seeing the light that would expand as it heads towards you.
Agree.
Yeah, there's no glare visible in image.
For the sake of rigor, you don't argue with him. You can use the back of the napkin to make your point, but what Ranty's saying is the rigorous, correct thing, right? You have no issues with that. Like, to really isolate the silhouette of the sun, right? You would
to doubt that that's the width of the sun, I think, is pretty poor. And again, illustrates my point that the burden of proof is stupid.
You can say that. You can say that. That's fair. I mean, we're allowed to analyze different things, but what he's saying, whenever you measure angular size, all those different things that you guys do, obviously that filter needs to be there.
Sure.
To ensure. Okay.
I'll take a photo of the sun with a solar filter on as it rises, and it'll be half a degree wide.
But you're quoting that angular size of the sun, dude, just for any image that you see. That's just be careful with that. Don't do that. I don't want you to get in trouble.
Do you disagree that the sun is half a degree wide?
Yeah.
Have you ever measured it?
No, I don't even know how that would work.
Yeah.
We would need to know the path that it's on.
Roohif, are you talking about with a solar filter?
Oh yes, yeah. I mean, if you got glare, you can't really measure it.
Right, but how do you know there's no glare in this image?
Because it's not like, how can I show you a photo of a glare?
Okay, have you ever stared at the sun when it's safe to do so, Roohif?
Have I ever stared at the sun when it's safe to do so? What does that mean?
Yeah, that's correct. Well, at sunrise or sunset, you can stare at the sun safely.
Yep. There's much less glare, right?
Okay.
You're getting less rays.
No. There's still glare, but when you stare at the sun at that angle, you are able to then, your eyes will filter out the actual size of the sun. You'll then see the actual sun, right? So if you were to do that if you could go back in time to this photograph, stare at the sun, you would see the glare, and you would be able to discern the size of the sun through it, just like you would at any other time. So it seems to me special pleading on your part that you're saying, there's no glare here. Well, first of all, we can't go back and recreate this scene, so you can basically claim a victory there, except for the fact that we'll go, nuh-uh, there is glare here, but we just can't go back and recreate this. Okay, but I think Ranty's point is a very, very valid point, and that is that you are assuming that you're actually seeing the physical, the dimensions that you think represent the actual size of the sun, which is my point about the actual size of the mountain.
And yet, I can overlay the actual elevation data onto those photographs, and it matches to a sun that is half a degree wide.
Yeah, where did you get your scale? Where did you get your overlay?
Where to get the data from?
No. What are you going to... How did you verify that the shape of that mountain is to scale?
I overlaid elevation data on it. So there's a couple of peaks there, right? There's Canigou itself, and then there's one called Dry Peak or something. You can work out an angular distance between those two peaks. You can say there might be, you know, 1/10 of a degree apart or something, and therefore again apply that scale.
Tilted back. I'm not actually trying to be annoying, but did you?
Well, that's quite an annoying question. The azimuth angle does not care about tilting back. We're talking a left to right angle at the moment.
Okay, I need to think about that.
Right.
So,
well, let me go back just real quick. Again, it seems to me that you think that you can simply apply raw data to the image. I don't doubt that you can identify one of the peaks. What I'm challenging is that you can claim that the scale is correct. Like if you're looking at a map and it says 1 inch equals 500 miles, right? I mean, you kind of take it for granted that that's accurate. 1 inch is 500 miles. But what I'm saying is, I don't believe, because of what I understand about refraction, that you can accurately and confidently apply raw data to the image and just say, yep, that's exactly it.
It is exactly it. That's exactly what you do.
You can't prove that. All you can do is claim it, Roohif.
No, I can show it to you, and I've shown it in a video before.
All right, well,
I can take a heading. I can take a heading to 2 of the peaks that you can see in this photo, and on Google Earth it'll say this one is at, I don't know, 270 degrees, and the heading to the other peak is 271 degrees. Therefore, there is 1 degree difference. That is how you can derive a scale that you can use, and therefore show that the sun is actually half a degree wide.
Okay, if you would put that link in the chat, I'll make sure to watch your video.
All right, I'll do it after the stream.
And make sure to sub to the Plain Truth, Roohif. Don't
He's usually commenting pretty quickly on my videos. I should actually resub, shouldn't I? Yeah,
we don't like this voodoo, man. Don't put these little scales and squish stuff. It just makes us uncomfortable.
You're denying perspective then. If you don't allow the scaling.
Yes. The way you're doing it, absolutely. I would never do that. I wouldn't even want a flat Earth proof to rely on that. That just makes me feel dirty just looking at that.
You guys say to us that we're denying perspective all the time, right? What I'm demonstrating here is perspective. It is angular size. It is perspective.
You're not taking into consideration the Aether band, Roohif.
Yeah, that's correct. I'm not taking it into consideration.
Right, that's your downfall. Right.
I will watch
the crux of all this long distance stuff and these curvy rays is we don't buy a homogeneous medium providing the ability for a ray to curve. No one. That's it for us.
It's not homogeneous. The atmosphere is not homogeneous. No, it's not. Go to the top of Everest and see if you can breathe.
No, we're talking about surface rays, man. Like near the waters, the layer, man. You can't weasel out of this, man. It's like 1 or 2, 3 feet chamber above the water. Yeah. Nobody in any academic institution would buy that, man.
Check the pressure. You've got a barometer in your phone, right? Check the pressure at floor level and then check it at the ceiling.
Yeah, Rumpus, the godfather, the premier optician, just so you know, that's what he labels himself, said it's a constant density layer in the chat. And I have a videotape, and I'm going to record that because that's, my...
I would say that he'd say it's a constant density gradient.
No, he said it's constant density layer that has a vertical density gradient, which I don't know. How is that possible?
Vertical density gradient, yes.
Yeah, how? Though it's constant density. There's 2 different
statements. No, not constant density. This is the distinction I made like half an hour ago. A duct is not an area of constant density. It's a constant density gradient.
But it has one density, one type of material.
No, it does not have one density.
Okay, so good. So now help us understand how is that possible that in such a thin layer you can have multiple densities. That's the original question.
That's exactly what a density gradient is. The density is changing.
No, but we're talking about 1 or 2 feet just right along the surface of the Earth. How can it vary that much away from the surface when it's that tight to the Earth?
It's just a very small variation over a very small
No, it's
height.
not very small. It has to be enough to curve the ray according to the Earth curve. So it's not.
Yeah.
We know exactly what the gradient is. It's the derivative of the surface of the Earth as you're traveling over, right? That's the direction that the ray has to change. So just by coincidence, that's what the gradient has to be, right? For k = 1.
Yeah. Do you want to get into actual measurements of refractive index and density?
No. I just
that's been
know
done.
I know what the definition is. K equals 1 means that the gradient, the density gradient, the medium is the same as the derivative of the shape. It just
same with
matches,
the curvature
right?
of the Earth.
Yeah, exactly. And so we're comfortable with that. So
Okay.
I mean, I
don't understand what this argument's about.
No, it's how does that happen physically? It's such a narrow layer where you cannot have a density change. That's how can it produce that curving ray? It can't, like, physically. You can say that there's one there that makes the ray curve, but that doesn't mean that there's actually a gradient there in real
do you accept
life.
Do you accept that conditions can exist for K to be less than 1?
No, because I'm struggling with the K1 value right now.
Well, I'm trying to get there.
Oh, sorry, K1 is not as curvy as Earth, right?
So the standard K is like 0.14, okay? And that's like standard refraction.
Yeah, that would be an actual gradient that can exist. Yes, so it's not tightly coupled to the Earth, so it has room to leave the Earth's surface, right?
Yes. Right.
Okay, yeah, that's
Do you accept that K can be greater than 1?
Well, I mean, let's explain 1 first before you start telling me to graduate to something that I don't even
as
believe.
we've said 1,000 times, K equals 1 is where the rays curve at the same rate as the curvature of the Earth.
Yeah, but they're in a medium that has no density change. That's our issue. Man. You can keep saying it, but none of us believe you. Like, definitely, I don't think Ali believes you. We know why that doesn't make sense physically. It's such a tight layer. You cannot put a gradient. When you talk about gradient, you're talking about a delta change, right? You take a derivative of constant, you get 0, right? So there is no gradient in a constant medium environment.
So there is a K. There is a K less than 1, and there is a K greater than 1.
We'll give you the less than 1. We're worried about the 1.
Okay, so the oil platform photo where the horizon is clearly above eye level.
Yeah, you even think that's greater than 1, right?
Yes.
Yeah, that's just don't take me there because I don't even agree with 1. You're going to an even more ridiculous claim that's saying that somehow the gradient is even no, but you're saying with the greater than 1 that the gradient is actually even more aggressive than the curve of the Earth, right?
Yes,
that's what you're.
Correct.
Yes, we're not going there, man. No, none of us are going to buy that. Well, because you haven't even explained how when K equals 1 exists, will that ray turn?
If conditions can exist such that K can be less than 1 and greater than 1, there will be a point, albeit a fleeting point, where K equals 1.
No, but less than 1 actually gives the ray room to breathe and leave the thin layer on the surface. That is somewhat plausible. We're worried about this tight layer above the Earth's surface. That can't happen, man. You're on the wrong team.
It happens when K equals 1.
Yeah,
should we use a different?
No,
measurably.
Yeah.
Measurably.
Along the surface of the Earth, there is no room, literally, for that chamber to produce a gradient. It can't. It's thin and constant over the surface of the Earth. Now you woke up George. George is in the chat now. He can't sleep,
George.
and Rumpus can't sleep. So look what you guys are doing, man. All right, I rest my case. Sorry. Thanks for your time, though.
You rest your case. All right. Who's left then? Travis still there? Ali still there? Are there any questions in the chat?
Yeah, I'm still here. I'm going to go because I'm up in a couple of hours. So I'll just say, Ranty, nice one, mate. Thanks for the chat. Thanks, Roohif. Thanks, Mind of God, Travis. Good stuff.
Cheers.
Cheers, Ali. Cheers, Ali. See you later.
Well.
All right.
Yeah. I'm going to listen anyway, but I'm going to fall asleep because I'm up in 2 hours to do some work, but it's only a couple of work. So, all right, guys, have a good one.
Right,
okay.
Good night.
Yeah, good night, guys. And thanks to each other as well.
All right, questions in the chat. Anyone?
Plain Truth, do you want to have anything to say?
The only thing I will correct myself, Roohif, when I get notifications that you post, those I do watch. I don't watch everything else, but so the ones that I do comment on are ones that I have watched.
All right, I will sub to you after this, all right?
I appreciate that.
Thank you.
And you can watch my episode on the vanishing line, and if you don't want to listen to me sing, that's fine. Just put it on mute, but you'll get the idea from the picture. But I think I've got quite a large cache of images that I can provide data that's going to support a lot of the things that we've talked about.
All right, Ranty, do you want to have a chat? What do we got to chat about?
I've got about another 5 minutes before I drop. I've been going for over 4 hours, so I was hoping that, mind of God, maybe if you wanted to just get your final points in with Roohif, and then we'll round up.
Yeah, we're good. I think I appreciate the time. I know that you were outnumbered in this panel, so I didn't mean to do that, but I think that we're at that stage now. You know, I think it's good. Everybody can have their opinion on math and physics. I think it's good that we've articulated what side people stand on, but I appreciate your time, man. Take care, Roohif.
Cool.
And thanks, Ranty.
Yeah, no worries. And I think, if next time you come on, Roohif, maybe talk about something different. I'm sure there's plenty of panelists that I can bring on that are more specialised in certain subjects. Maybe I don't know, maybe Earth tilt. Who knows? We'll see.
Yeah, I'll talk about anything. So if I don't know. So all good.
Yeah, and I mean, obviously, your guys on your side. You know which ones are stronger in certain points. It's whether or not you can convince them to come on this show and debate people that that I can get in panelists from our side to debate your panelists from your side in the specialities that they would consider them a specialist in.
Yeah, all good. My wife doesn't get back for another 8 days, so I'm while the cat's away.
Whilst the cat's away, indeed.
I can dig around online.
Right, okay, right. So anyway, guys, with that, I hope everyone enjoyed that. Thanks for everybody that stopped by. Lots of people been going over for 4 hours now. All the people that smashed the super chat, thank you very much. And I'm going to round up now, and I'll see you all in the next one.